Okay, so what we've seen is that if we have a function y equals f of x, then f prime of x is the slope function for f of x. Okay, so we've seen that f prime of x is called the derivative of x. Another way to refer to it is the first derivative of f of x. Okay, we also have other derivatives of higher orders of a function f. Okay, so namely, after the first derivative of f of x, we have what's called the second derivative of f of x, and that's denoted by f double prime of x. Okay, so as I said, that's the second derivative of f of x. So at this point, you might be wondering how we would define the second derivative of f. Okay, so we found that the first derivative of f gives the slope of f. To get the second derivative of f, we simply differentiate the first derivative. Okay, so f double prime of x is just the derivative of f of x. All right, let's see an example of computing a second derivative, and then we'll see what it actually means. How do you interpret it? So let's let f of x equal, say, 3x minus x squared. I want to find the second derivative of f. So I want to find f double prime of x. Well, since f double prime of x is the derivative of f prime of x, the first thing that I need to do is find f prime of x. So f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. To get f of x plus h, we just go to these two x's and we plug in x plus h. So this is equal to the limit as h approaches 0 of 3 times x plus h minus x plus h squared then minus the function, so minus parentheses 3x minus x squared. So that's all divided by this h here. Okay, so let's clean this up a bit. So we have the limit as h goes to 0. I'm going to distribute the 3 and multiply out the x plus h squared. So we get 3x plus 3h minus a quantity. X plus h quantity squared is x squared plus 2xh plus h squared. And then minus this, I'll get rid of the parentheses. So minus 3x plus x squared all divided by h. So we get the limit as h goes to 0 of, if we clean this up, we can cancel the 3x, that 3x here. Why isn't it canceling? Okay, there. And that 3x will cancel there. Let's see, we can distribute that negative sign into the parentheses. So we get 3h minus x squared minus 2xh minus h squared. Then we have plus x squared here, all over h. Okay, now we're going to get more to cancel. So this x squared goes away. Again, for some reason, they don't want to go away. Okay, now, that x squared goes away. And we're left with the limit as h goes to 0 of 3h minus 2xh minus h squared all over h. Now we can cancel an h. Let's see if these will want to go away. So let me take an h out of this numerator. So we get the limit as h goes to 0 of h times 3 minus 2x minus h all divided by h. All right, so these guys need to go away. Good, they went away this time. So we get the limit as h goes to 0 of 3 minus 2x minus h. And now we're ready to take that 0, substitute in for the h. So we get 3 minus 2x minus 0, or just 3 minus 2x. So we just found that f prime of x is equal to 3 minus 2x. Okay, so now let's take a look at the problem again. We wanted to find f double prime of x. Well, f double prime of x is the derivative of f prime, so therefore, to get f double prime, we need to differentiate this. So, because all we know right now is how to find a derivative using the definition, that's what we're going to have to use to now find f double prime. So, f double prime of x is equal to the limit as h goes to 0 of f prime of x plus h minus f prime of x, all divided by h. So now we have the limit as h goes to 0. Here we take this x plus h, plug it into the x in our f prime of x. So it's 3 minus 2 times the quantity x plus h. Then minus f prime of x, so minus the quantity 3 minus 2x, all divided by h. Okay, here we can distribute that negative 2, clear those parentheses, and we get the limit as h goes to 0 of 3 minus 2x minus 2h minus 3 plus 2x, all divided by h. We're going to get things to cancel here. So the 3 goes away. Yay, finally this time the pink would work. The 3 cancels with the negative 3, the negative 2x cancels with the 2x. So in the top, we're left with negative 2h. So here we get, okay, this thing stalls. So we get the limit as h goes to 0 of negative 2h divided by h. The h's cancel, okay. And so therefore we get the limit as h goes to 0 of negative 2, which is just negative 2. So what we just found, I'm going to leave it in pink instead of green because this thing is stalling on me. Okay, so what we just found is that f double prime of x is equal to negative 2. So here we have our original function. F of x is equal to 3x minus x squared. We found that the first derivative is 3 minus 2x, and the second derivative is negative 2. All right, I'm going to give you one to try, and then we'll take a look at the interpretation. Okay, so in this case, let f of x equal 2x squared plus 3. I want you to find f double prime of x. Press pause while you work on it. Okay, so first we're going to find f prime of x, so that's equal to this limit here. Next, you're going to multiply this out and take care of the negative. Okay, next we will cancel the 3's and distribute that 2. Right now we'll get rid of the 2x squared. Okay, next we will factor out an h. Then we can cancel the h's and evaluate the limit. So we have the limit as h goes to 0 of 4x plus 2h, and we substitute 0 in for the h, we get just 4x. Okay, so f prime of x is 4x. Okay, next we need to differentiate this. I know that the graph of this is a line, and I know that the line has constant slope. Since the derivative of something measures its slope, I already know that the answer is going to be 4. Okay, so I'm going to touch on that after this, but now I just want to kind of give you a heads up of where we're going to go, but we'll go ahead and do this out. So for f double prime of x, we have f prime of x plus h, so we have 4 times x plus h, minus f prime of x divided by h, so we'll distribute the 4. Next we can cancel the 4's and simplify, cancel the 4x's and then simplify. So we get the limit as h goes to 0 of 4h over h. The h's cancel, and as I expected, we have just 4. Okay, so in this problem here, we have f double prime of x is equal to 4. Okay, so at the beginning of the video, I reminded you that f prime of x gives you the slope of the graph of f of x. Therefore, f double prime of x gives you the slope of the graph of f of x. So it gives you the slope of the graph of f prime of x. So in a way, it's telling you how the slope, okay, so because this is slope of f double prime is telling you how the slope of f changes, okay, so the slope of f. Okay, so here we have the graphs of f prime, and f double prime for the function that we were just working with. So if we take a look at this here, we see that for these values of x, the slope of the graph of f is positive. The slope of the graph of f is negative, and that's why this function here is below the x-axis. That's why f prime is below the x-axis there, because the slopes are negative. Here, the slopes of the graph of f are positive, and that's why we see that the slope, that's why we see that f prime of x is above the x-axis there. So if we take a look at the graph of f prime of x here, we see that the slope here is always the same. The rise over the run is the same no matter where we go, because it's a line. And so that's why we see that f double prime is horizontal. It's a horizontal line, because f double prime gives the slopes to the graph of f prime. Okay, so that's the way each of these works. F prime gives the slopes of f double prime, or the second derivative, gives the slopes of f prime.